Good morning, guys. Welcome to today's lesson, April 20th, area of a sector. Let's take a look at today's do now. In the diagram below, triangle ABC with sides of 13, 15, and 16 is mapped onto triangle DEF after a clockwise rotation of 90 degrees about point P. If DE is equal to 2x minus 1, which is right here, what is the value of x? Now, think about what they told us. They said a rotation took place. That means we know a rigid motion, right? We have a rigid motion. That means the sides don't change, the angles don't change, really nothing changes except for the position where the triangle is located. It just moved around. Its sides didn't change, its angles did not change. Now we need to know, what side length does DE correspond to? They gave you the letters ABC and DEF. That notation is important because that tells us that DE maps onto AB. So that's the same side length here as 16. So 2x minus 1 and 16 are the exact same thing. Be good to also mark off everything else. BC, let's see what BC is the same as. EF. CA is the same as DF. Sometimes it's difficult to really visualize where the sides ended up, but if they give you the order of the letters, use it. So we know 2x minus 1 is the exact same thing as 16. So you can set up your equation that they're equal and solve. We get 2x minus 1, 2x is now equal to 17 after we added 1 to both sides. Now divide 2 on both sides and we get x is equal to 17 over 2, which is equal to 8.5. Choice 4. Alright, our aim, how do we find the area of a sector? Now, in the simplest terms possible, the area, or what a sector is really, it's just a piece of a circle. That's all it is. So let's first look at this Explorer and just look at a plain old circle. Find the area of the circle below. Leave your answer in terms of pi. So just thinking about this whole circle, all right, how would we find the area? Well, this is a formula you should know, but if you don't, it is on your reference sheet also. The area of a circle is equal to pi r squared. Leave your answer in terms of pi, so it's just pi times the radius, because the radius right now is equal to 4, halfway across the circle. So pi times 4 squared. Leave the pi, don't multiply by pi just hangs out at the end. So this would be 4 squared is 16 times pi, and it's units squared. They didn't give us units, so we just write out units squared. So 16 pi. Now, let's see below that. A sector is a part of, right? It's a part of the circle. It's the area between two radii and the connecting arc. Remember, arc is just a piece around the circle. Make a prediction for how much area the sector occupies of the whole circle. So the sector is the two radii, all right, and essentially all the space in between the two radii. So it's like essentially it's like a piece of pizza. All right, you're taking a slice from the pie. It's just a part of the overall circle. So how much area does that sector, how much area does that take up? Do you think it takes up maybe a half? Does it take up half the circle? Absolutely not. Too small. Does it take up a third of it? No. Does it take up a quarter of it? Actually, it doesn't even take up a quarter of it. All right. What amount it actually takes up, we can find out very easily. We just have to understand what this formula is first. So area of a sector. That's equal to x degrees over 360 degrees times pi r squared. Now, we have to understand what that is. So this pi r squared right here, that's just the area of a circle. Now, what they added was x over 360. What is that? What is x over 360? Where is that coming from? So it says to find the area of a sector, right, we're going to use this formula to find the area of a sector of a circle, provided the radius or the diameter, and x, the central angle. The big idea here is x, the central angle in degrees of the sector. So this right here, I'll just make a side note, x, we need the central angle. That's just the angle that's in the middle of the circle. It meets at the center. So in addition to that, the central angle we have to understand 360. So this is your central angle, right? It meets at the center, 60 degrees. It's an important piece of info. That's our central angle. Now, where's 360 coming from? Guys, 360 is the total amount of degrees in a circle. 360 in total. So it's essentially saying our area is equal to something, the central angle, over 360 degrees times pi r squared. So the same exact formula, except we have this fraction in front of it. So you're multiplying, essentially you're multiplying the area of the circle, you're multiplying it by a fraction. Why? Because a sector is a fraction of the circle. Now, the actual answer to this, all right, for your prediction, was 1/6. Where am I getting 1/6 from? Well, 60 over 360, that simplifies to 1/6. So this sector occupies 1/6 of the circle. So you're essentially, once again, you're just finding the area of the circle and multiplying it by that fraction, and you'd be multiplying it by 1/6, or 60 over 360. All right, we're not going to simplify this one. We have a bunch of examples to go through. But your understanding of area of a sector is it's the exact same thing as area of a circle, except we just have a fraction in front. That fraction is what percentage of the circle, all right, what percentage of the circle is that sector taking up? All right, the way you find that is the central angle over 360. Why 360? Because we have 360 degrees in total. All right, example 1. In the diagram below of circle O, diameter AB and radii OC and OD are drawn. The length of AB is 12, and the measure of angle COD is 20 degrees. So, before we read the rest here, let's just fill in a couple things here. They gave us 12. The length of AB, that's the diameter. So our radius is 6. All right, 6 and 6. All right, and it really would be 6 here, but just for space. All right, there's a bunch of radii in there. So we have a radii. All the radii are 6. And the measure of angle COD is 20 degrees. Now, they wrote it all the way like towards the arc. The 20 degrees is really right here. They just couldn't fit the writing in there. That would be 20 degrees. All right. So now let's keep going. If arc AC is congruent to arc BD, so this arc AC is equal to this arc BD, find the area of sector BOD in terms of pi. So sector BOD, there's a bunch of sectors. We want to focus on sector BOD here. So that piece. Think about that. Let's kind of make a prediction. Does that occupy half of the area of that circle? No, not quite. That piece is too small. All right. So we have to use the piece of info that they told us of the fact that AC, the arc AC, is congruent to arc BD. So this angle here, the central angle there, and the central angle there, x and x, those are equal to each other. How do I know that? Because the arcs are equal. If the arcs are equal, the central angles have to be equal. All right? So now, what do we have here if we lock in on these three angles together? It's a linear pair, a linear bunch, a couple angles, right? 3 angles in this case actually. 3 angles that add to 180 because that occupies half of the circle. There are 3 angles on a straight line together. Remember, a straight line is also 180. So you can set up an equation to find the central angle. Now, hold on, why are we doing this? What's the formula? The area is equal to x, the central angle, over 360 times pi times the radius squared. Now we have the radius, we don't have x though. So we have to find that central angle. So you can set up an equation of x plus 20 equals 180. You get 2x plus 20 equals 180. X and x, right? That's 2x. Subtract 20 on both sides. We get 2x is equal to 160. Divide by 2. And you get x is equal to 160 divided by 2, which is 80 degrees. All right? So this is definitely more of a challenging one, but given the fact that the video can only last a certain amount of time, I want you to see how challenging this can get. All right, the central angle, it's very, very important that you have the central angle if you're finding the area of a sector. They're going to make it confusing sometimes to find that central angle. All right, but at the end of the day, we get 80 degrees and 80 degrees there. So that's your central angle. All right, let's keep going. Let's substitute now. Our area is equal to the central angle of 80 over 360 degrees in total times pi times the radius squared, which is 6 squared. Now we're leaving our answer in terms of pi, so all we need to do in our calculator is multiply. You don't want to multiply this entire thing because that's multiplying with pi. We want to leave our pi at the end of our answer now. It's in terms of pi, so it's multiply 80 over 360 and 6 squared, and then just leave the pi at the end. So we go to our calculator here. It would be 80 over 360 times 6 squared. So that gives us 8. 80 over 360 times 6 squared is 8. So our area of this sector is equal to 8 pi. All right. And you could write units squared as well. With area, units are always squared. Example 2. This one diagram is a little more straightforward. So don't give up on this yet. Focus on this one. Should make a lot more sense. Ready? Circle O with a radius of 9 is drawn below. So you have your radius. Good. Radius, very important for the formula. The measure of the central angle for angle AOC is 120 degrees. All right. What is the area of the shaded sector of circle O? So your formula, let's remember that. X over 360 times pi times the radius squared. Here's what students are going to do. Ready? Our area is equal to 120 over 360 times pi times the radius squared. I want you to think about what's wrong about that. If you could pause the video and just think about, hey, what did I do wrong? At 120, that's a central angle. 9, that's the radius, yep. Guys, the problem is they said shaded sector. The shaded sector, yeah, it's this radii, these radii here, but the shaded sector is around this way. So we're finding a big portion of the circle here. We're not using that 120. All right, just to think about it, your central angle of 120, that means that arc AC, right? Arc AC is also equal to 120. So what would the remaining piece be for the arc going around the circle the other way? What's the remaining portion? Well, it would be 360 minus that 120, which would be 240. So your central angle here essentially is 240 degrees. Right? 120 and 240, that makes 360 total. So careful with that wording. They usually talk about, in these regions problems, they talk about the shaded sector. All right, so read carefully. All right, it wasn't as simple as, 120, put it in the formula, 9, put it in the formula. You had to think, you had to use your knowledge. And just like the last problem, guys, all right, if you know what the central angle is, you know what the arcs are. That arc is 80. This arc is 20. This arc is 80. All right, the central angle and the arc are equal to each other. So 120, 120, and then 240, 240. So let's substitute what we have. Our area is equal to 240 over 360 times pi times 9 squared. Our answers are in terms of pi. Look at choices 1 through 4. So the pi just comes along at the end here. The area is equal to something pi. Multiply this out. 240 over 360 times 9 squared. Oh, 240 over 360, it's actually 2/3 of the circle. All right, times the radius squared times 9 squared. And that comes to 54. So 54 pi, choice 4. All right. Now, if they ask you for the area of the sector, guys, here's your formula. It's actually not given to you on the reference sheet. It would be something you'd have to memorize. So your area is equal to, just think about pi r squared and how there's a fraction in front. All right. You need the fraction to be the central angle over 360. However, you're going to see problems like example 3 here. Ready? In the diagram below of circle O, the area of the shaded sector, AOC, is 12 pi inches squared. So they gave you the area. Essentially, it's 12 pi. And the length of OA is 6 inches, and they filled that in for you. Determine and state the measure of angle AOC. So what's different here? They gave you the area, and now they're asking you for the central angle. A bit tricky, but let's substitute what we have. Write your formula. The area, right, is the central angle over 360 times pi times the radius squared. So this would be, we have the area, so let's substitute our area, A, that's 12 pi, is equal to x over 360, we're looking for the central angle, so x is the unknown, times pi times the radius squared, which would be 6 squared. Now remember, at this point, with the capabilities of GeoGebra, which is pretty fascinating, you can just substitute that in and then find your x-intercept, find where the line crosses the x-axis, and you'd be done. But let's talk algebraically, because we are, moving hopefully onto Algebra 2 next year. So, what would we have to do to solve here for x? We have to isolate the variable. Well, guys, I see pi on both sides. We can get rid of that. All right. Now, what else? 6 squared, we got to simplify, right? So this would be 36. And now you could divide that. Let me rewrite that. We would what's left now is 12 equals x over 360 times 6 squared, which is 36. Now the way you would solve that from here, right, we're getting everything away from x. So you'd have to divide out this 36 here to the other side. Now 12 over 36 comes to some crazy decimal. It's 0.3 repeating, and that would be weird to write out. So you can just leave that as 12 over 36. And now that's equal to x over 360. Now this is just a proportion, just like if we were doing similar triangles. We cross multiply. So 36 times x is 36x, and now that's equal to 12 times 360. 4,320. Divide by 36 on both sides. And you get x is equal to 120 degrees. Does that make sense for that angle? Does that angle look like 120 degrees? Should, yeah? Always check. If that angle came to 300 degrees, you would know, hey, I did something wrong. Or if it came to something bigger than 360, right, it's impossible. It has to be something from 0 to 360. All right? Once again, at this point, if you're struggling with the algebra, at this point, you're just substituting everything you know. At that line right there, you could put that into GeoGebra and solve. One more together, and then you'll try examples 5 and 6. And then if you're good to go, you're good to go. You can try it out on your own. In the diagram below of circle O, the area of shaded sector, LOM, they're giving you the area again. The area of shaded sector, the shaded sector, LOM, is 2 pi centimeters squared. If the length of NL, which is here, is equal to 6, what is the measure of angle N? So this right here. So what we have to do here, guys, is actually find the central angle there, because all we know is the area of that sector. So if I know the area of that sector, the shaded sector there, I can do what we just did to find the central angle, and then that should end up allowing us to find angle N. So angle N, I'm going to call that N, so that it's not the same exact thing as X there. Okay, so we're going to find X. Now, we need the central angle. That's what we're looking for. We have the area, which they told us, and we need the radius. Be careful, don't use 6. We have a radius of 3, half of 6. So let's substitute, right? Our formula is equal to x over 360 times pi times the radius squared. They gave us the area, 2 pi. That's equal to x over 360 times pi times the radius squared, which is 3 squared. So area 2 pi, they gave it to us. X over 360, we have to find x, the central angle, pi, and then the radius squared. All right. Now, we're not going to go through algebraically solving this time, at least for the video. You can if you'd like. I'm just going to show you in GeoGebra we can also get the answer. So exactly as we substituted, 2 pi equals x over 360 times pi times 3 squared. Enter. That's exactly as we wrote it. Scroll. $80. That's your central angle there. So using GeoGebra there, we got x is equal to 80 degrees. Does that angle x right there look like 80 degrees? I buy it, yeah. That's 80 degrees. So that opens up. Now from here you just have to use your knowledge of angles dealing with circles. That means that the arc over here, ML, is equal to also 80 degrees. And that enables us to find N there, the angle they're asking us for. Watch as N opens up. It intercepts the exact same arc. However, it's a different relationship. That's not, for N there, that's not a central angle, that's an inscribed angle. N, right? inscribed. It meets on the circle. The inscribed angle is equal to half of the intercepted arc, so half of 80 would be 40. You could see how many students will do a really nice job here, but end up with a final answer of 80. Be careful, the central angle is 80, that gives us the arc, however the inscribed angle is equal to half of that arc, so we get 40. So try examples 5 and 6. This one you're just finding the area in terms of pi for each. Just practice substituting into the formula. The next one you're going to practice finding the central angle. Alright guys, I will post your Delta Math today so you can get going on that. Ask me questions and remind. This is very, very new. Don't hesitate. Alright, have a wonderful rest of your day, and I'll see you Monday.